Hey, hello everyone. Can you guys hear me?
Yeah, Sumit.
Hey, Gaurav, how are you?
Yeah, I'm good. Thanks.
Hey, hello guys. Hello everyone.
Hello, Sumit.
Hello, Alex. So, we'll wait for another 1 minute and then we are going to kickstart. Meantime, I'll just set up the rest of the things what are left.
Okay, fine.
Gaurav, the previous logins what you had given to me, they are not working. Am I supposed to use something different?
You can use this one also. That I don't think so. Is there any difference, or you're facing any issue?
I'm not able to stop the device. Just let me try to close the lab. No, believe there is some user issue with this one.
So the user ID and password is not working, or what?
No, I'm not able to close the lab with this user ID and password.
1 minute. Let me check the user ID password again. 1 minute.
Yeah, and what you had pinged me earlier, those are not working. Or maybe, hold on. I guess I have to log into different. Now I guess they should work.
Yes, because that's for CCNP security.
Yeah, but I'm able to log in. Okay, this is, I believe, should I stop this or someone else is using? What is the scenario?
You can stop this, or even you can create your own also. It's totally up to you.
Okay, this should be good. One last thing to do, and then we are good to trigger.
So guys, today is a day one for CCNP Enterprise, and initially we are going to start from the ENCOR and then later on CCNP and RC. Correct, Sumit?
Yep. I see still people are joining, so I guess it's fine to. Okay, this is good. Okay, just give me 1 second. Okay, today we are going to speak about Inter-VLAN routing. It means last time we had seen this topology where we were expected to, or we saw how exactly the communication works between same VLANs and how exactly the access and trunk plays the role. Now, today we are going to talk about Inter-VLAN routing. This will clear out your concepts of how exactly the routing happens, irrespective of it is a switch or it is a router. Router performs a lesser function as compared to the switching part, but from a switching perspective, how exactly the L3 switch behaves whenever it gets a packet and it needs to do both the functions at layer 2 as well as at layer 3. Okay, now what do you mean by inter-VLAN routing? Whenever you are communicating between two different VLANs, right? A simple topology, if I draw, and if, let's assume this is my L3 switch and I have connected two machines to it, where my machine 1 IP address is 10.1.1.1/24 and PC2's IP address is 20.1.1.1/24. Now, my first question, are they part of same subnet or different subnet?
Different, sir.
Different subnet, right? Now, if they are part of different subnet, how exactly the forwarding would be happening from PC's perspective, as well as when that packet or that frame is received on the L3 switch, how exactly it is forwarded. These are the important factors what you need to understand. Is that right? Now, if we talk further, if we talk about the basics of how exactly PC1 and PC2 are going to communicate, I had specifically given this one statement where whenever you are having a same subnet, you will use ARP to find out MAC address of remote machine or remote PC, in this case PC2, correct? Now, what is going to happen if they are going to communicate between two different subnets? What is the most important factor we need from a machine's perspective or end host perspective?
MAC address, sir.
Yes, MAC address is by default present, but we need to have something. We need to define something on our PC
IP, sir.
side.
IP.
You define IP. Let's say you might define the IP address 10.1.1.1/24. What else you will define on the machine, PC1 or PC2?
Gateway, sir.
Gateway, which is default gateway, correct? Now, who is going to be the gateway of PC1 in this case?
L3 IP, sir.
Yeah, it is going to be L3 switch IP or whatever we configure, whatever VLAN we configure this machine in. So let's assume that here I have two VLANs configured, which is VLAN 10 and another one is VLAN 20. Under VLAN 10, I have configured the IP to be 10.1.1.100/24. Whereas on VLAN 20, I have configured the IP to be 20.1.1.100/24. Now, do you see that the IP present or IP configured on PC1 and the VLAN 10 IP, they are part of same subnet?
Yes, sir.
Right? This is /24, this is /24. It means we have how many n number of hosts we can use in this? 255 minus 2, which is equal to 253, right?
Yes, sir.
Now, from that perspective, who is going to be our default gateway? 10.1.1.100, right? Is everyone able to understand?
Yes, sir.
Okay.
Yep.
Now, moving forward, now do you see if these two IPs belongs to same subnet, it means ARP is going to work on it, right? So if this and these are same subnet and ARP always works in same subnet, right? So that is how PC1 will be able to find out what is the MAC address of its default gateway. And whenever this PC will create a packet, let's say we have pinged to 20.1.1.1. Let's do a packet walk. What is going to be my source IP address?
10.1.1.1.
10.1.1.1. What is going to be my destination IP address? To whom I am pinging?
Default gateway, sir.
I'm talking about destination IP address.
20.1.1.1.
Yes, 20.1.1.1 because I am pinging that IP address. Correct?
Yes, sir.
Now this specific data will be forwarded to which layer, and these are part of your network layer as per OSI, right? Where does IP works?
Network layer.
Network layer. Then after network layer, you have to push the data towards
Data link
which
layer.
layer? Data link layer. Now, if we speak about data link layer, what we need? Source MAC
MAC address.
and destination MAC.
Yeah.
So let's assume PC1's MAC address is A, VLAN 10's MAC address is B. Here on SVI it is B. VLAN 20 on SVI is MAC address is C, and PC2's MAC address is D. Okay. Now, what is going to be the source MAC address?
A. Yes, sir.
A is going to be the MAC address. Now, this is most important factor. How will machine decide which MAC address to pick? Because it don't know the MAC address of PC2 because they are part of different subnet. Correct?
Default gateway, sir.
Yes. This is where what it will do. It will pick up the default gateway MAC address. And how exactly it will do that? Because these two being part of same subnet, they are able to pull the data via sending the ARP request towards L3 switch. And from that perspective, it will decide that it needs to send the data to destination MAC of D. Correct?
Yeah, right.
Sanjay, can't hear you.
Right, sir. Right.
Anyone having any kind of doubts till now? Feel free to shoot. I'm giving 30 seconds time. Should I consider that as no from everyone?
So, broadcast and flooding, what is the difference?
We'll talk about it once we are done with this. Let me complete the flow on this one, and then we'll speak about broadcast and flooding. Okay. Now, okay, thank you for the confirmation. Now, what will happen? This specific packet will reach out to L3 switch, correct? Yes or no? After that, L3 switch
Yes,
will do the decapsulation, and what it will find out that in data link layer, what is the destination MAC it has kept? The destination MAC belongs to L3 switch itself, correct? Yes or no?
Yes, sir.
No, this should not be D, this should be ideally B. Because here VLAN 10 SVI's MAC address is B, correct? Now from that perspective, it will find out that L3 switch, whenever this packet is reaching to L3 switch will find out that in the data link layer, the destination MAC address belongs to me itself. And that is the reason it will be able to find out that you have to do the routing part. It has to do the routing of the packet, or it has to do the switching of the packet. It is decided on these terms. Now, here is most important factor. The moment it will see its own MAC address into it, it will strip off all these things. The data link layer will be stripped off totally. Understood?
Yes, sir.
Any kind of doubts? Once this is stripped off means it is removed totally. Once it is removed, then it will find out that then it will refer the network layer. So at this layer, it will be 20.1.1.1 is the destination, correct? Yes or no? After that, what L3 switch will do? L3 switch will find out first that 20.1.1.1 it is connected to itself. That's why it will be referring the routing table. Once in the routing table, it will see is as connected. It will go to which table? ARP table. Why it will go to ARP table? Tell me.
MAC address table.
To find out the MAC address of PC2, correct? Now it will find out that against 20.1.1.1 MAC address D is present, and once it will find out the MAC address, or it will find out the MAC address with the help of ARP table by checking the IP mapping to the MAC address. It will refer to which table? This I have already explained in my previous lecture. So in those terms, it will refer the MAC address table to find out the next hop. Next hop in terms of physical interface through which it has to send out the packet. Clear? Any kind of doubts till now? Okay, I'm considering that as no. Now it has to recreate this data link layer again. Now what is going to be the source MAC and what is going to be the destination MAC? Someone needs to tell me.
So source MAC is a B, destination MAC is D.
Source MAC is going to be what?
L3 switch, sir.
L3
D.
switch. But
D.
which one? VLAN 10 or VLAN 20?
VLAN 20, sir.
So VLAN 20's MAC address is
C.
C. So what is going to be the source MAC address? C. And what is going to be the destination MAC address?
D.
D. Why D? Because it knows that 20.1.1.1, which belongs to the PC2, have a MAC address of D assigned to it. How it was able to find out? With the help of ARP table, correct? And from there, it will decide that it needs to send a packet out to whom? To PC2. This is how the end-to-end communication is going to happen between different VLANs. Any kind of doubts till now? Feel free to ask. You are having any kind of doubts, you are open, you need to ask.
Sir, for the first R packet, destination MAC address is 10.1.1.100.
Yes.
So then router sends the R packet for VLAN 20.
Router sends the ARP packet for VLAN 20. No. What it will do? See, PC1 decides that PC1 will check out the moment you hit a ping. PC1 decides that source IP or its own interface IP and the destination IP are part of different subnet, correct?
Yes, sir.
Now, if they are part of different subnet, what is going to happen?
Routing, sir.
Yeah, absolutely. But from PC's perspective, there is no routing, right? From PC perspective, they are not bothered about all these things. What PC knows? PC only understands one thing, that it needs to either send it knows where to send a packet. Now, in this case, what do we expect? What do we expect? That my PC should be sending. This is again creating a problem. Give me a moment. I'll draw it. There is some issue with this pen. Yeah. So what it will do? This is my L3 switch, or let me try to. Okay, it is killed. What it will do? Let's say this is my L3 switch. Here I have two SVIs, VLAN 10. IP of VLAN 10 is 10.1.1.100 and VLAN 20. IP here is 20.1.1.100. MAC address which belongs to VLAN 10 on SVI is B. Here it is C. This is my PC1. This is my PC2. The MAC address which is configured here is A. Here it is D. Now the IP what I have configured here is 24. Your question was that why exactly it will send the ARC for 10.1.1.100, right? The problem here is because ARP only goes or ARP only works in same subnet, correct? This is clear. I'm not sure who
Yes,
asked me
sir.
this question.
Yes, sir.
Akshay. Yeah. So ARP only works in same subnet. The moment you are hitting the specific command of ping 20.1.1.1, your PC knows that the source IP address configured on the local interface versus the IP to which this machine is trying to reach out, are they part of same subnet? No, right?
Yes, sir.
So from that perspective, it decides that what it needs to do. It have to send a packet towards default gateway. And to send a packet towards default gateway, what it needs to do next? Tell me, it needs to know the MAC address, correct? MAC address of default gateway. Is that right or
Yes.
wrong?
Yes, sir. Right.
So to know the MAC address, what it will do? PC will refer the ARP table. In ARP table, it will try to find out. It already knows what is the default gateway configured. And from default gateway, it will try to find out, do I know the MAC address of 10.1.1.100, who is my default gateway? If it don't know the ARP, or if its ARP table is not having the entry for 10.1.1.100, then it will initiate the ARP request for 10.1.1.100. Clear?
It's clear, sir.
Any kind of doubt?
No.
Okay, Saurabh, I'm sorry I could not use Hindi because we have someone from outside. Probably I'm seeing multiple names over here, like Alex and Demian. Apologies if I'm pronouncing it wrongly, but they will have understanding issues in those terms.
No issue, but a little bit, only a little bit.
I can't hear you.
Okay.
For my side, it's okay. I am catching everything that you are explaining to us.
Sorry, did someone say anything? It was
Yeah,
choppy.
it's me, Alex. Yeah, I am
Yeah, Alex,
understanding
tell me.
everything. Yes. Yeah, I am understanding everything that you are telling to us. For my side, it's okay.
Okay, no, there was a requirement to use a local language, which is Hindi. That's why I had to specifically tell him. Okay, understood in terms of how exactly the forwarding would happen whenever there is a inter-VLAN communication. If yes, we'll move to this lab first, do a small lab, and then move to next topic. I'll show in that how to create VLANs we have already seen. I'll be showing you how to create the SVIs. What are SVIs? This is a way you can configure IP addresses to a VLAN, a specific VLAN. It is called as SVI. The full form of SVI is Switch Virtual Interface. Okay, I'm considering that as all understood. I've picked up a L3 switch and I'm going to pick up 2 machines now. Let me do the Windows. I don't want to confuse. Okay, this is a question to all the people who have joined my last lecture. What will I configure here on Ethernet 0x1 and 0x0? Will I configure access or will I configure trunk as a port?
Access.
Access, exactly. And second question is, I'm able to recollect what question I wanted to ask. Yeah, does VLAN do in access mode? Does it do the tagging or is it untagged traffic?
Untagged traffic, sir.
Untagged traffic.
Yes, and when we speak about untagged, it means no tagging at all, right? You're just opening up the machines. And this is good. What I have to do? Windows 2 and Windows 3. Let me connect them accordingly. So what am I supposed to configure on Windows 2? It is part of VLAN 10. What is IP address I will use here? 10.1.1.1, correct? And what is going to be my default gateway?
100.
100. This is configured without any problem. And let me move to Windows 3 machine. In Windows 3, it is going to be 20.1.1.1. And my default gateway is to be 20.1.1.100. Correct?
Correct, sir.
Now, first I will do what I will do. I will show you the ARP table of one machine. What do you see? Do you see any entries for 20.1.1.1?
No.
No. Even if you try to ping 10.1. We have already tried this, but I just want to show you. We are not going to get any kind of reply. Reason, we don't have anything configured anywhere, right? Now, what I will do on my switch on Ethernet 0x1, I'm going to configure it to be part of which VLAN? VLAN 10, correct?
Yes, sir.
And all I have to do is under interface 0x1, I have to say it as access, correct?
Yes.
And how to configure the SVI, okay? Interface VLAN 10. This is a command to configure the SVI. You have to use the exact same numbering. You can't use something like you have configured a VLAN with number 10, but here you are using VLAN 20 or VLAN 100. It is going to exactly pick up the same values to have the communication done. Once interface VLAN 10 is configured, All I have to say is IP address 10.1.1.100, correct? And if I show you the status, my SVI is up. I have assigned IP address to it, and status as well as protocol is up. And this is very important that both of these values, both of these things should be up for the
Your voice is
communication to be
breaking.
true. And another important factor you need to understand that at least one port should be part of that specific VLAN or SVI for the SVI to be up. When I say this, let me show you what happens if my interface Ethernet 0x1 goes down. Let's try this. This is only one port where I have configured. This is only one port where I have configured SVI in terms of VLAN 10. So if I show you this, let's check what is happening. Good, as expected. Platform issue. I have manually shut down all the ports. Still, VLAN 10 is not going down. This is a hardware problem. This is an emulation problem. What image we are using. If I change the image and bring up something else, it is not going to give us any problem. I'll show you at the end of the lecture. So this is up at this moment. Now, if I try to ping,
Sir, your voice is breaking again.
can you hear me now? Is it good? Hello? Rest of the guys, can you hear me, or is it really a problem?
No, I can hear.
Sorry?
Yes, sir, it's clear.
Thank you. Now, the moment I hit a ping, did my ping worked? Yes or no?
Yes, sir.
And if I show you the app table, do you see I have an entry for 10.1.1.100?
Yes, sir.
Now you need to tell me or think logically that why first packet took a time of 119 milliseconds to receive a reply, whereas second and third packet had a reply in 1 millisecond. What will happen on this machine? What exactly it will do step by step?
Due to actually if
Sanjay, I can't hear you.
I will not get within it will be drop the packet.
Sanjay, I can't hear you.
Sir, because in first our packet we have no MAC address of our destination, sir.
Yes, exactly. So first step, what it will do, it will initiate the ARP. It will wait for ARP to be completed, and after that it will send a ping. To send the ping first, it needs to know the source MAC, destination MAC, and all those details. But those details are incomplete. That's why the first packet is taking more time to get completed as compared to next packets. Understood?
Yes, sir.
Any kind of doubts? If you see now, till I have my ARP entry to be present, I'm not going to face any kind of problem. I'll try to, we can see if we are able to clear out the ARP entries. I can Google it maybe. Clear ARP from Windows.
Sir, RPD.
Thank you.
ARP-D.
ARP-D. Everything is cleared, I believe. Let's validate. No ARP entries found. Right? Let me try to ping again. This time it is faster because we got a reply and the entries are created. Oh, then now it is faster. For first time, I believe the behavior is different. We'll try to validate the same thing on Windows 3.
सर एक क्वेश्चन था
Yep.
स्विच में मैक एड्रेस क्लियर करने की कमांड क्या है?
Clear MAC address.
क्लियर मैक एड्रेस.
This is the command. And then you can exactly add whatever MAC address you want to clear, or you can clear the whole MAC address of the switch. Okay, should we move ahead? We have only configured half of the part, which is from Windows 2 towards switch. If we move from Windows 3 to switch, I have to configure Windows 3 now. What I have to say?
Clear the MAC for a particular device, then
Particular device, then this is the command, clear MAC address. Let me show you the MAC address now. Show MAC address. These are the entries present, right?
and for the whole system.
Yeah, so if I want to clear out the MAC address, the very specific one, I have to say clear MAC address dynamic, then select, then write down address, and then whatever address I want to clear.
Okay.
Do you see the address is gone?
Okay, in that case, we have to mention the address.
Exactly. For a particular system, whenever you want to clear out something, what is identity of the system? MAC address.
For particular system, right, sir?
Yeah, for particular system. Every system is having a MAC address, right?
Right, sir, right.
Just one moment. Let me bring the charger.
Sure.
I'm back. So, understood how to clear out the MAC address?
Yes, sir.
Yes, sir. Yes, sir.
Okay. Now we will configure the second part of this, which is VLAN 20. First, I'll create the VLAN. Then I will assign it to the interface. And I have to create the SVI. IP address to my second SVI is 255.0. Now, one thing what I forgot to show you is that every SVI also gets the MAC address. And if I show you it for SVI 10, you see there is a dedicated MAC address assigned to it. Correct?
Yes.
And if I do it for 20, it has picked up something else or same. Yeah, it is same. Okay, let me also bring it up.
You just put show the VLAN 10 or 20 for the MAC address, right, sir?
Like this? No, these are system-based MAC addresses. There is a difference. These are the MAC addresses which this switch will only assign whenever you are going to create an SVI, or else these will not be created. Okay.
if we want to get the MAC address of VLAN, then what was the command, sir?
Yeah. So if you want to see the MAC address of specific VLAN, you have to see show interface VLAN 10. And from that, you will be able to see what is a MAC address assigned to this specific SVI.
Okay.
Okay. Same way, every dedicated machine or every dedicated SVI will get a MAC address without any problem. And that's how the forwarding is going to happen. So in this case, what is going to be the behavior? That SVI 10 and SVI 20 both have been configured. They have their own dedicated MAC addresses. And if you see, they are up. Now, if I show you the ARP table entry, we see there are dedicated ARPs already generated for these machines. Do you see this? Or another way, what you can check is via the ARP table, you can find out the ARP and MAC addresses assigned to those. So for 20.1.1.100, this is a MAC address assigned. For 10.1.1.100, this is a MAC address assigned. Eventually they are same, but on a real hardware, the situation is going to be different. You will see a dedicated different MAC addresses assigned to them. And this dash means they are never going to be aged out because they are locally configured here. Now, if I show you, if I just configure, if I try to ping 20.1.1.1, this specific is an IP address which belongs to my Windows 3 machine. You will see I know the R for 20.1.1.1 also. Any doubts till now?
Sir, is this possible practically? We are getting same MAC address for both individual
Not
VLAN.
for SVIs, yes, sometimes it is possible. This is moreover a development which happens on platform to platform basis. When I say platform to platform, it means within Cisco there are different number of hardwares, correct? One is Nexus, one is Catalyst. Now it totally depends on the specific developers how they want to deploy these things. So yes, it is practically possible. And there is, I believe, Nexus 7K in which this behavior happens.
Okay.
Okay, I am not able to recollect the exact hardware, either it is 7K or 9K, but whenever you create a SVIs or even a physical interface, they assign a same MAC addresses to it.
Okay, sir.
Okay, any doubts till now?
Sir, I have one doubt.
Yeah.
Sir, now time I am using two hosts.
Okay.
But real in this stage we are lot of hosts, 50,
Yes.
70.
Yes.
How can I find 49 hosts to MAC address?
How can you find
49 number host MAC address?
49 number? Don't
Yes.
be bothered about the number. So whenever you mean as per sequentially the 49th number in the ARP table entry. What
Yes.
do you mean by 49th host?
तो सर मेरे पास 50 होस्ट हैं और मेरे को उसमें से 49 नंबर जो होस्ट है उसका मैक एड्रेस पता लगाना है। कैसे
वही
पता
तो मैं
लगाऊं?
बोल रहा हूँ कि आपको 49th नंबर किसके पर्सपेक्टिव से हुआ? एक होता है कि सुबह से जो ऑफिस में आया है वो पर्सपेक्टिव से हो सकता है, एक हो सकता है कि आई मीन 49th नंबर का ऐसे कोई होस्ट नहीं होता, जो कनेक्टेड है वो सारे इक्वल है, उसमें नंबरिंग करके कोई सीक्वेंस नहीं दिया गया किसी को।
I think he is just asking about the IP address if we are using 192.16.10.1
then that is a part of your DHCP. Are you talking about DHCP का requirement है या आपका? You have to be very specific in terms of कि 49th host मतलब क्या, कि 49th host जिसने कनेक्ट किया था वो बहुत कुछ हो सकता है ना उसमें तो, या पोर्ट वाइज 49th host?
पोर्ट वाइज 49।
ओके, सो वैसे क्वेश्चन, तो अगर इमेजिन करो कि 48 पोर्ट्स का स्विच है ऑलरेडी, बराबर है,
yes.
और उसके ऊपर 4 पोर्ट्स और है, या तुमने 96 पोर्ट का स्विच लिया हुआ है, राइट? नाउ यू हैव टू फाइंड आउट that on interface 1/0/49, who is the user connected? Is that your question?
Yes, yes, yes.
Okay, so from that perspective, you know that on what port you want to see the MAC address, correct?
Yes.
So what all you have to do is show MAC address, table, interface, and then whatever port you want to see. So in this case, you have asked me for 49, but we don't have 49 over here, right?
Yes, yes.
So what I will use is, just for explanation purpose, I will use any one port, let's say 0/1, and it will show me that on Ethernet port 0/1, what is a MAC address I am learning. And if you know what is a MAC address you are learning, you can find out from ARP table that what is the IP assigned to it. So if you see what I did, मैंने show IP ARP किया, फिर include बोला और ये MAC address डाल दिया.
Sir, in that case, ARP table first it will find na where is my 49 number. पहले तो वो find करेगा table में.
अच्छा, नहीं. You need to understand the behavior. First, what was the requirement? Requirement was to find out who is a 49th host, correct? It means whatever port we have on whatever user we have, which is connected on a one specific port, right? ARP table is only about mapping between ARP, mapping between IP and MAC address. Your ARP table don't show you the entries of interface. It is not showing you the exit interface. Physical interface दिख रहा है क्या आपको? नहीं. What you are able to see is a SVI, right? Now this is a bigger difference when a router performs the things as compared to where a switch performs the things. Does router have MAC address table?
Okay.
No, sir.
No. So how does router decides who is going to be the exit interface?
IP address.
IP address. But once you do the destination IP lookup, you will refer the ARP table, right? Yes or no?
Yes.
Now, if you are going to refer the ARP table, from ARP table, you will find out, okay, this is a MAC address mapped to a dedicated IP address. But then how will it decide what is going to be the exit interface? On which interface it has to put the packet in a physical format, like light or electrical signal. First, and that this specific data in router is picked up by your ARP table. Whereas because we are talking about SVIs or we are talking about L3 switch, there is an additional function done that if you refer the ARP table, it is not going to show you the exit interface. It only shows you that 20.1.1.1, which is I'm picking as an example, is part of VLAN 10, right? But VLAN 10 could be permitted on 10 different interfaces. That is possible, right?
Hey, sir.
And from that perspective,
My office.
okay, I put him on mute. And from that perspective, it has to refer the ARP table first and then MAC address table. So Akshay, was that your question, or Sumit, that was your question? कि पहले ARP table होगा कि पहले MAC address table होगा? Totally depends on requirement. Because here Saurabh का requirement was कि एक port पे कैसे ढूंढना है, that I was telling. Is everyone clear till now?
Yes, sir. Yes, sir.
Yes, sir.
Should we move ahead?
Yes.
Okay, now how are going to things, how the end-to-end communication is going to happen? I am going to hit 20.1.1.1. I'll explain it now step by step. The moment I am going to hit this specific command, 20.1.1.1, it already knows that physically it is configured as 10.1.1/24, right? They are part of different subnet. Because they are part of different subnet, it will try to send the traffic to whom? Default gateway, correct?
Yes.
The moment I'm going to send a traffic to default gateway, my source IP is going to be 10.1.1.1. Destination IP is going to be 20.1.1.1. Source MAC is going to be A. Let's assume this is A. Destination MAC address is going to be the gateway MAC address, and from where it will pick that, it will be picking it from this ARP table. From this ARP table, it will find out whatever is a MAC address mapped to 10.1.1.100, which in this case is this. And that's how this machine will forward the packet towards the gateway. Now, if I try to ping, you see the ping is working. And if I show you the ARP table, does ARP table have any entry for 20.1.1.1? Is anything seen over here?
No, sir.
No. Why? Because both belongs to same subnet or different subnet?
Different.
Different subnet. That's why ARP is not going to work in that. Okay.
Okay, sir.
Any kind of doubt till now?
No.
Okay. Now this is done. This part is explained how exactly the SVIs are going to function. Now let me add some more things into it. So when I say some more things, what do you mean? What do I mean by that? Ideally, in our offices setup, we always see the redundant part, or we always see there are two switches in the setup, primary and secondary, right?
Yes, sir.
Now, from that perspective, how do we anticipate the traffic to flow end to end? Let me bring out the things first. How exactly is my topology going to look like? This is going to be my first L3 switch. Name to that is switch 1, connected to switch 2. Here it is going to be PC1, and we already have PC2. This is part of VLAN 10. This is part of VLAN 20. This is again my PC3 and PC4. This is going to be part of 10. This is going to be part of 20. These 4 ports are going to be in access mode, right? Now, what from switch perspective? Switch 1 to switch 2. How do we expect?
Trunk port. Trunk port.
Yes, they are going to be trunk port.
We are using both the switch as a redundancy.
You can consider that. Now, what I will do, SVI 10 will be configured here, as well as SVI 20 will be configured here. Okay. Here also, I'll be using SVI 10 as well as SVI 20. So let's assume what IP address, the IP address what I will give here is 10.1.1.100. Here it is going to be 20.1.1.100. On right side, it is going to be 10.1.1.200. Here it is going to be 20.1.1.200. PC1's IP address, let's assume, is going to be 10.1.1.1. And PC3's IP address or PC4's IP address is going to be 20.1.1.1. Is everyone clear about topology? Or any kind of doubts?
Very clear.
Okay, now I'm going to ask you the question. You have to think about it. Let's assume I do a ping from PC1 to PC4. What is going to be my source IP and what is going to be my destination IP? What is going to be my source MAC and what is going to be my destination MAC? Yeah, someone needs to go ahead. Tell me the answers.
Sir, source IP is 10.1.1.1.
10.1.1.1. Destination IP is going to be
20.1.1.1.
20.1.1.1. So who is going to be the default gateway on PC1?
VLAN 10, sir.
VLAN
Switch 1
10.
VLAN.
10.1.1.100, right?
Yes, sir. Yes, sir.
And for PC4, what is going to be the default gateway?
20.1.1.100.
20.1.1.200, right?
Yes.
Now, this is my network layer. Let's move to next layer, data link. What is going to be my source MAC? Let's assume the MAC address here is A. MAC address of SVI 10 here is B. Here it is C. Here it is D. Here it is E. And here it is F. What is going to be my source MAC and destination MAC?
Source A.
Source is going to be A. And what is going to be my destination MAC?
Switch 1 destination, sir.
Can't hear you.
So switch 1 MAC address.
Switch 1 SVI 10 MAC address. Why? Because source IP and destination IP belongs to different subnet. Whenever source and destination belongs to different subnet, the packet will be sent towards default gateway. Correct?
Yes, sir.
So if it is going to get sent towards default gateway, by that means only MAC address change is going to happen. Your source IP and destination IP is going to be always same, right?
Yes, sir.
So the destination MAC address here is going to be B, correct? Because
Yes.
this is the MAC address what it owns. This packet will be reached out to switch 1. Now tell me what switch 1 will do.
So switch 1 MAC address is B. Destination MAC address is D. PC4D, sir.
Okay, yeah, here it is confusing for a lot of people. You are absolutely correct if it is router. And this is where maximum people's routing concept gets cleared. So listen to me very carefully. First of all, imagine this frame, this whole frame has now reached to switch 1, right? Correct? What it will do? Decapsulation process. How exactly decapsulation process starts? This is a part of your CCNA. First physical layer, right?
Yes, sir.
Then
Network layer. Physical, sir.
once physical is done, what will be there after that?
Data link.
Data link. So physical is done. Next, data link, DL. What will be there in data link layer?
MAC address.
MAC address. What it will do? It will open up the MAC address. It will check out who is the destination MAC address of this frame. What is the destination MAC address? B.
B.
B for Bombay. So B belongs to SVI switch 1's MAC address because this is basically configured here locally, right? Yes or no?
Yes, sir.
You guys are not clear. I will explain it again. That's
Yes,
not a
sir.
problem.
Against.
Yes means you are clear, or should you want me to explain it again?
Against.
Thank you. Now, do you see the moment we created SVI, there was a MAC address assigned to it, correct? Yes or no?
Yes, sir.
That MAC address is ideally the default gateway. This is the default gateway configured on PC1, right?
Right.
It means whenever PC1 will try to send a ARP request for the default gateway, it will send the MAC address details which is mapped to this IP address.
Yes, sir.
Right?
Right.
We just saw it in the ARP table. What is that MAC address? That MAC address is B, correct?
B, correct.
That MAC address will be added in your data link layer and the packet will be forwarded to switch 1. Is everyone clear till now?
Yes, sir.
When switch 1 will receive it, your CCNA concept triggers in, which is decapsulation process will start. And in decapsulation at layer 2, the MAC address will be coming in. Imagine yourself, you are the switch. You have opened up. It is like doing the surgery of the packet. You are opening up and you found out, okay, source MAC address is A, destination MAC address is B, correct?
Yes, sir.
Now this destination MAC address belongs to switch 1's SVI 10. Is that right?
Sir.
Yes or no?
Yes, sir.
Can't hear you guys.
Yes, sir.
Thank you. Now, when it will find out this specific thing, it will strip off the whole Ethernet frame. Why it will do that? Because it finds out it needs to do the routing part on it, correct?
Correct.
And then if this has been stripped off, what exactly will be the next step done? It will go to which layer? Network layer. This is removed now, right? Once this is removed, what is left? As per decapsulation process, once data link layer is removed, what is the next layer?
Network layer, sir.
Network layer. In network layer, what it knows? Destination IP address, correct?
Okay. Correct, sir.
Yes or no?
Yes. Yes, sir.
Destination IP address. Here it will be referring the routing table. What it will find out? 20.1.1.1 is connected to me. You have configured the SVIs, right? It means it
Yes,
is
sir.
directly connected to you. If I show you on switch 1, show IP route, what do you see? 20.1.1.1 or 20.1.1.100. This specific subnet is connected to you, right? We are talking about subnet, not single IP. Is this over now? Is this going bouncer? If yes, I will stop now and we will start again with this new topology.
Sir, no problem, sir.
Should we continue? Should we stop? See,
Yes, sir. Continue.
you have to understand this. You are the learners. And if you're not going to understand, there is no point, I will move ahead because this is most important from a packet flow. And maximum engineers don't have a clarity about packet flows. So you need to be exception. If you're sitting in my batch, you need to be exception in those terms. So tell me, should we continue or should we stop?
Continue, sir.
Continue, sir.
Okay, thank you. So do you see this is shown as directly connected? Do you see this? Yes. In the routing table, this is seen as directly connected. So if it is directly connected, can I check the ARP table to find out the MAC address? So there are some basic things. You will, whenever there is something directly connected to you, it means you will have to know its MAC address. You need to have the entry into the ARP table to proceed the packet further. Yes or no? Yeah, I'm waiting for someone to answer if you are able to understand or not.
Yes, sir, we are able.
Thank you. So if that is the case, this is important. You have to understand this. how exactly things move. A packet is received on the switch. Switch will do the decapsulation process. Under decapsulation, it will check for destination MAC. If destination MAC belongs to switch itself, it will remove the whole Ethernet frame and do the next step of decapsulation, which at this stage is your network layer. In network layer, it will check for destination IP address. In destination IP address, it will compare it with routing table. In routing table, if it finds it as directly connected, it will try to check for ARP table to find out what is a MAC address against it. Your source IP and destination IP is not going to change at any point of time. That's why the whole switching ideally happens on the MAC addresses. And this is where from ARP table, it will find out what is a MAC address present, and then it will create a new Ethernet frame, and that's how it will forward the packet to next interface. This is an overall step-by-step process on how exactly switch is going to forward the frame at L3 level and L2 level, and what are the important factors which are required in this. So coming back to the topology, let me remove this. So whenever this specific frame will be received on switch 1, or this packet will be received on switch 1, it will check the destination IP address. And if it will find out that it is directly connected to it, why it is directly connected to it? Because SVI is already configured here, right? The destination SVI is matching 20.1.1.100/24. This is matching with your destination IP address in terms of subnet mask. Yes or no?
Yes, sir.
After that, switch 1 will do the checkup for ARP. Now, for which IP it will do the ARP lookup? For destination IP address, because it is directly connected. If it is directly connected, ARP lookup will be done for destination IP address. Once that is done, from ARP table, it will find out the MAC address. From MAC address, it will find out the exit interface. And what will be that exit interface? The interface going towards switch 2, right?
Yes, sir.
And what will be the source MAC and destination MAC it will put now? Source MAC is going to be the MAC address of SVI 20, because this is where your packet is going to get egressed. It is going to get exited from that interface. So my source MAC address is going to be C, whereas my destination MAC address will be F directly. This is important. This is most important part of inter-VLAN routing. Once this is done, switch 2 will receive the frame, and switch 2 will only check for destination MAC address and directly forward the frame towards PC4. I know this is a bit tricky, and that's why we are going to cover it again tomorrow from scratch with lab. As of now, we are done.
Okay, sir.
Gaurav, you are around? I believe Gaurav has dropped. So whatever further lectures will be there, Gaurav will inform you about those, but continuation will be from this same topic of inter-VLAN routing.
Sumit sir, Smith this side.
Yeah, tell me.
Sir, any notes or book?
You have to prepare your own notes. I don't believe in giving the notes. Reason being, if I keep giving you the notes, you will not watch the videos.
Okay.
Just for your information, I have read CCNP switching book for 35 times till now in last 10 years.
Okay, sir.
Okay, and I never make the notes. Same reason. If I make the notes, I'll not read the book.
Sir, please provide the book, sir. Blueprint book, sir.
Sorry?
Sir, please provide the blueprint book.
Blueprint book.
Just
I-
ask
Yes, sir.
for interview perspective, sir.
Interview
Yes, sir.
perspective, things are very different. Interview perspective, someone will ask you, what is which loop is more harmful, L2 loop or L3 loop? Now, if you haven't opened the packet or if you haven't done the Wireshark, you will not be able to answer which loop is a more harmful loop. And from this perspective, I am already covering this specific requirement of packet walk, which is asked in maximum interviews. If you go with a good interviews like Microsoft or AWS or Cisco or maybe Juniper sometimes, this is important. These are the questions what they ask. A packet flow, because packet flow is very important. If you need to understand the routing, understand the problem, you need to understand how exactly packet flows from source A to source to destination.
Sir, watching the videos again and again is not possible. So please provide the book, sir.
Book, I'll give you the name of the official guide. You can go through that, but apart from that, there is nothing much that I can give. I can give. I'll give the name. I don't have any PDF for that, to be frank.
Okay, sir.
Okay. See you
Yes, sir.
tomorrow or whenever Gaurav plans for it. Probably from tomorrow the lecture will be starting, but he'll inform you as well as he'll inform me.
Okay, sir. Okay, no problem.
Okay. See you around.
Thank you, sir. Thank you very much.